Hello. Let's make an equilateral triangle by rotating side lengths. You can make equilateral triangles lots of different ways, but we want to practice using transformations. So the first thing we do is we get on the construct tool and we use the segment tool to make a segment. Make sure you make it generally like this. So when I say that I want it to be diagonal and have a decreasing like a negative slope. That way, whenever you click the right and left points, like the instructions say, it'll work out where you can still see it on your screen. So next we want to go to transform, define transformation, and click rotation. It says choose a point for the center. We're going to choose the right endpoint. We are going to now rotate by 60 degrees, which is 60 degrees counterclockwise. That will give us the side length in this location. So we'll just type that in, click what we want to rotate, which in this case is our segment, and then click apply. So there's that one. And I just kind of click off of there for my next thing, which is to rotate this segment again, but to do it clockwise. So do it negative 60. So we're going to define another transformation. It's going to be another rotation. We're going to choose our left endpoint as our center. We're going to type in negative 60, click this segment, and only apply the new rotation, so rotation 2. And voila, we have an equilateral triangle, but we do want to check that it is indeed equilateral. So back to construct. We're going to plot the point that is the third intersection. And if you just kind of hover over the intersection, it'll lock on there and you just click. Notice the, let's say, shadow of the point is smaller than the shadows of the points over here. That's because it's telling us it is a true intersection. So now we want to measure these side lengths. And the angle measures, it doesn't matter which one you start with. I'll just do side lengths. You just click with the select tool and then click label, and we should find that these are all the same. Now the number we see here is arbitrary, meaning it can be different for each person's triangle they create. However, it will be true if you've truly made an equilateral triangle that all of these have the same length. Now we want to measure our angles. You'll need 3 points though, or one leg, a vertex, the other leg. So I typically will do the points, but because I don't really like having extra points here, so I just kind of click on a point that's already a vertex to make it look a little neater. So there's that one, and we'll repeat those steps for the other 2 angles like so. And now we have 60 degrees. So we should all have 60 degrees as our angles because triangles sum to 180 degrees in their interior angles, and if we divide that by 3, we get 60. Let's see what happens when we select one of these points and move them. So notice, because this point is an endpoint of the segment we've rotated, the rotations still apply. You can move things around. No matter how you move it, your side lengths are the same and your angle measures are 60 degrees. And if you try the other points, this one, since it's the intersection, kind of just moves it around in general, and this other one should also move the side lengths. So now we have all proportional side lengths from this triangle to this triangle. The side lengths are proportional, but the angle measures are congruent.